Hello everyone, and welcome to the study guide for grade 11 quarter 2 test. I would say better late than never, and I think I'm going to stick with that. I actually made a video just now, but what had happened was there was police outside and sirens were going off, and it was just a bunch of havoc and confusion, and you can hear it in the background as I'm talking and trying to give a lesson, if you will. So I decided to make a new video because my first one was ruined. But let's jump right into it. Number 1. This is a topic you need to know. How to calculate hydronium or hydroxide ion concentration in a solution with a certain molarity. So in this case, the example I'm giving you is that I have a 4.3 molar solution of sulfuric acid. And in order to answer this question, you need to know how to name compounds, and specifically in this case, sulfuric acid, which I hope you know by now is H2SO4. So I have a 4.3 molar solution of H2SO4, sulfuric acid. The question is, what is the hydronium ion concentration? So concentration is moles per liter, right? So if I have 4.3 moles per liter of this stuff, and now I'm looking for just hydronium, which is going to be influenced only by hydrogen. That's all I care about. So how many moles of hydrogen are going to be in this solution, which would give me my hydronium? It's very simple. You just multiply this by the subscript. So 4.3 times 2, which is going to equal 8.6 moles per liter. Yeah, that's it. It's pretty straightforward. The next question looks at how to calculate the concentration of hydroxide or hydronium with a given pH. So the first one, I'm not given pH, I'm given the molarity, right? In this case, I'm given pH. So what is the hydronium ion concentration in an aqueous solution with a pH of 3.44? So my pH is 3.44. How to solve for this? If I'm given the pH and I want to find out the concentration of hydronium, I have to now use this equation where I set 10 to the negative pH value. And that will give me the hydronium ion concentration. So in your calculator, you'll type 10 to the power of negative 3.44, and that will equal, or should equal, 0.000363, or in other words, 3.363 times 10 to the negative 4. Alright? So this is if I have the pH. And the question is, what is the concentration of hydronium? I have to use this equation here. What if the question was, this is not on the study guide, but I'm just asking this for fun because we all just love chemistry so much. What if the question was, if the pH was 3.44, what is the pOH? What is the pOH? I want to change my color to purple. You should know the equation that pH plus pOH is equal to 14. So here we have 3.44 plus pOH is equal to 14. I'm going to subtract 3.44 from this side, subtract 3.44 from this side. So POH is equal to 10.56. Let's keep going with this because I'm liking this. So we have a pH of 3.44. We have a POH of 10.56. The original question was, what is the hydronium ion concentration in this solution? If the question had been, what is the hydroxide ion concentration? The first step would have been, which we did, is to find out what is my POH. And then I could do that same equation of trying to find out my hydroxide ion concentration is going to be equal to 10 to the power of the negative POH, which in this case is 10.56. So 10 to the power of negative 10.56 is equal to, you can pause the video now, or you can continue the video as you like, but if you put this in your calculator, you should get 2.75 times 10 to the negative 11. So the way to look at this now is that this is if I'm given a pH value or POH value and I'm trying to find out concentration. So I'm not given the concentration. If you're given the concentration, you're going to use a different formula. So number 3, how to calculate the pH from a given molarity. Molarity is concentration. So the example is, what is the pH of a 0.43, and I believe I forgot to put M there, molar, HCl solution? The equation I'll use for this is that pH is equal to the negative log of the hydronium ion concentration. Some people put H+, some people put H3O+. It's talking about the same thing, right? So in this case, what is the pH of a 0.43 molar solution of hydrochloric acid? Notice here that the subscript is going to be 1, so I don't have to multiply it by anything. So this will simply be negative log of 0.43. And that's going to be my pH value, which in this case is 0.36. Fantastic. Number 4. What are the characteristics of acids and bases? Acids are sour. Acids are corrosive. Acids turn litmus paper red. If it's blue litmus paper, it becomes red. If it's red litmus paper, it becomes red. And another thing that we learned, which will also be touched on in number 7 of this study guide, is that acids are a proton donor. They donate the different protons that they have, and in this case it's primarily hydrogen. Okay? If you write donor as donor, then it's a type of food, so be careful with that one. Okay? And the other thing is characteristics of a base. Bases are slippery to touch. They feel like soap. It's kind of slippery. They taste bitter. They turn litmus paper blue. And the easy way to remember that is that bases are blue and acids have a D in it, acid, and those are red, and that has a D in it as well. And finally, that a base is a proton acceptor. It will take the hydrogen. Okay? So bases are proton acceptors, and acids are proton donors. Number 5, know the 4 different reactions that acids have with different metals. Number 1 is if I have an acid with a metal, this is a simple metal, not bonded with anything, so if I have HCl plus Cu, or H2SO4 plus Mg, I have an acid and a metal. What are my products going to be? I'm going to have H2 gas, they're going to be bubbles, plus whatever salt I'm going to get. All right, so in the first one I would have copper 2 chloride maybe, and the next one I guess magnesium sulfate, which you could buy at the pharmacy actually. Magnesium sulfate makes really cool crystals, which we could try in lab. If you buy magnesium sulfate, let me know. Let me know in the comments below, and make sure to like, and we can maybe do that in lab. Okay, so that is a gas evolution reaction. It makes hydrogen bubbles. The next type is if I have an acid with a metal oxide. Metal oxides are those like K2O, potassium oxide, or magnesium oxide, or calcium oxide, or what's another good one that kids love? Maybe copper 2 oxide, right? In lab, some of us looked at, we had iron powder, Fe. It was just supposed to be iron powder. And when we put the hydrochloric acid, we noticed there were no bubbles. There was no H2 gas being given off. That's because what had happened is that the iron had reacted with the oxygen in the atmosphere all around it, and it became FeO. So now it's iron 2 oxide. And because it was iron oxide, we didn't see any bubbles. It just the reaction, the products were water and salt. So we didn't see any bubbles forming. We just saw the stuff kind of sitting there. Some of us saw little tiny bubbles, tiny bubbles. Maybe there was some of the iron that was left that didn't react with the oxygen. But otherwise, yeah, it was an interesting experience for some of us. Number 3, if I have an acid and a metal hydroxide, for example, lithium hydroxide or sodium hydroxide, all I'm going to have there is water and salt. There's not going to be any bubbles created. Number 4, if I have an acid and I add to it a metal carbonate or metal bicarbonate. So this would be, for example, sodium bicarbonate, right? So what are my products going to be? I'm going to have water. I'm going to have CO2 gas and salt. So this is making CO2, which is carbon dioxide, which is a gas. And that gas will create bubbles. It is a gas evolution reaction. Number 6, moving right along. Understand that acids and bases often react and have conjugate acids and conjugate bases. In the following reaction, what I, the acid and base, I should say what is, so maybe put an S there for fun. And what is the conjugate acid and conjugate base? The reaction is OH minus plus HCl, and that's going to yield H2O plus Cl minus. Don't forget our definitions of acids and bases, of being a proton acceptor or proton donor. So in this case, oh, poor Amin, if you can hear him in the background, he's crying. He misses his daddy. I'm a baby daddy. Okay, but I have to make the video for the kids. So I have OH minus. Minus means that it can take a proton. So this is going to be a proton acceptor. This will be a base. And HCl, it looks like hydrochloric acid. That's a proton donor, so that would be an acid. So what happened to the acid? It looks like it gave a hydrogen to OH, and now it's Cl minus. So now that it's Cl minus, it can now accept a proton, which makes it a conjugated base. And H2O now has the ability, it has an extra hydrogen to now give. Right, so this will be the conjugated acid. Fantastic, fantastic. Now, simply put for number 7, what is the Bronsted-Lowry definition of an acid and a base? And which of the above in question 6 are acids and which are bases? Bronsted and Lowry definition is what we've been talking about the entire time. And that acids are proton donors and bases are proton acceptors. So just like in question 6, in the beginning, what was my proton acceptor and what was my proton donor? Out of these two, my proton donor was this guy. So according to the Bronsted-Lowry definition, this was my acid. And also according to that definition, this was a, maybe I shouldn't draw an arrow to it. This is a proton acceptor, which means it is a base. Okay? Also now, if we look at the products, H2O and Cl minus. In this case, which one's going to be the proton acceptor? Cl minus. So that's going to be my base. And my acid would then be H2O. Of course, we know it's a conjugate acid, but it still behaves like an acid nonetheless. Number 8. Purple's fine. Know what anhydride acids are and what anhydride bases are. A very simple way to remember this is that anhydride bases have metals. Period. Make your life simple. So if I look at the first example, CO2 is an example of an anhydride acid or an anhydride base. If there's not a metal there, which there's not, it's an anhydride acid. And let's look what would happen if I have CO2 and I added H2O. This would become H2CO3. This is carbonate. So if I have this H2 here, this is carbonic acid. Cool. The other one, it says CaO is an example of an anhydride acid or an anhydride base. I have Ca, that's a metal. Okay, it's done. I'm done. It's an anhydride base for sure. If I add H2O to it, it will actually, because it has to be a base, it will have hydroxide. So it will be CaH2O2, which will actually be CaOH2. That looks more correct. Which is a base, calcium hydroxide. Finally, number 9. Know the definition of titration and the formula used to solve such problems. The example is if I have Well, first let's look at the equation. In my chemistry class, we used M of acids, M of acids, V of acids equals the same, but for bases. In Ms. Rania's class, which I think is more appropriate, we actually said the subscript of the acid times the molarity of the acid times the volume of the acid should be equal to the subscript of the base times the molarity of the base times the volume of the base. The example question is the titration of 15 milliliters, that's going to be my volume of my acid, so 15 milliliters of a 0.1 molar solution of hydrochloric acid it required 23 milliliters, so that's my volume over here, of lithium hydroxide to reach its endpoint. Its endpoint is when it's neutralized, it's finished. So what is the concentration of lithium hydroxide? That means I don't know my molarity. I do know my subscript, though, of LiOH. I only have one OH here, so it's just 1 times M times 23. I have that side done. On this side, I have the subscript of HCl, which the H is 1. So this will be 1 times 0.1 times 15. Okay, let's combine these together. 1 times 0.1 times 15 is 1.5. So that has to equal M times 23. Right? So now, using a calculator, what we need to do is divide both sides by 23, because this is being multiplied by 23. So divided by 23, that cancels out. Divided by 23, that means the molarity of my lithium hydroxide solution is 0.06. That's it. I hope you've enjoyed this video. Maybe watch it once or twice. If you have any questions, please email me or message me. I'll be up quite late tonight, but feel free to message at any time, and also I'll be available in the morning. Okay? Take care.